So good afternoon once more, ladies and gentlemen. In the morning, we looked at what we called what did we call it? We called it intra area. So now we want to look at inter area routing, OSPF routing. So when we were looking at intra area intra-area, we looked at two types of LSAs. Can someone remind me, what did we call the type 1 LSA? Someone?
Router.
Exactly. Router LSA. Then type 2?
Networker.
We have the network LSA. The network LSA. The router LSA is originated by what? Who produces the router LSA?
Every router in the autonomy.
Exactly. Every router in the area will produce a router LSA. Then the network LSA, who produces the network LSA?
The designated router.
The designated router. Very true. Now, this time, we're going to look at routing between areas, and we're going to look at an LSA called type 3 LSA. The type 3 LSA is normally called the network summary. Network summary. Is the summary ni A ama ni R?
Ni A.
Yeah. Network summary LSA. So we're going to look at the network summary LSA. This is quite a short topic, so we're going to take a shorter time to cover it. So as the network grows, with the structural complexity increasing, routers consume more memory. Simuliana kufanya hiyo calculation ya SPT. Doing the SPT calculation is not that easy. It consumes quite some memory space. And then also CPU resources for that calculation. So, moreover, the network failure rate also raises. If you're having more devices, then the probability of a failure occurring also increases. So if a fault happens in an area, all the routers in that area will have to recalculate their SPTs. Just because one link has gone down, it has to recalculate the entire. So these may place a heavy burden on the routers and also degrade the network stability. So how does the OSPF protocol work to handle problems caused by an overly large area? So an area that has so many routers. So by the end of this chapter, you should be able to. Ian, please help us.
So be familiar with the inter-area route transmission process.
Yes.
Understand how to prevent inter-area routing loops, and understand how to configure virtual links.
Very important. Okay, so let's look at inter-area route calculation. Now, generally, we looked at multi-area OSPF during the associate training on OSPF. We said that OSPF can be divided into what we call areas. And if you can remember, we mentioned about area 0, and we said that if you're just having a single OSPF area, then it should always be named area 0. Then all the other areas now can be named from area 1, area 2, and so on and so forth. The reason as to why we break down areas is to reduce the number of entries in the Lsdb, and to also reduce the burden on route calculation on routers. Because if the routes are so many, you see the SPT is going to be quite long, and it's going to consume quite some amount of memory and also CPU resources. So in order to ensure that the Lsdb is not so huge, then we divide, we put routers in different areas. So when you put them in different areas, if this link, for example, goes down, or anything goes down within this area, then only routers that are in that area will recalculate, and not all the routers within your network. So that's why we do the division. Okay, now we have certain routers. We have certain routers whose interfaces belong to two areas. So, for example, this router here, RTB. So it has an interface that is in area 1 and another interface that is in area 0. So these routers are commonly referred to as ABR, if you can remember, or an area border router. Then we also have what we call internal routers. So an internal router is a router which all its interfaces belong to the same area. Belongs to the same area. So for example here, RTA, RTD, RTE are internal, what we call internal routers. Okay, so why did we say that at least one area has to be named area 0? Why did we say at least one has to be named area 0?
Because communication between areas is through area 0.
Communication between areas is through area 0, and we're going to see why we say that in a short while. Now, something else to add. For example, this internal router, it will produce a type 1 or a type 2 LSA. So, number one, it must produce a type 1 LSA, which is a router LSA. Then, if it's the DR, it will also produce a type 2 LSA. Now, the work of the ABR is that it will convert this type 1 and type 2 LSAs into type 3 LSA and advertise it in area 1. So whatever it receives from that area, it's going to advertise it in area 1 as a type 3 LSA. So that's the main purpose of the area border router. So we are going to see how that happens in the coming slides. Okay, so let's look at inter-area route transmission. Inter-area route transmission. So here, I want to explain how this happens. So RTD is connected to this network segment 192.168.1.0. So this network segment will be carried in a type 1 LSA, in a router LSA, and advertised in area 1. So when it's advertised in area 1, it's going to be also shared with RTB. We know that RTB is an area border router. It's an ABR. So RTB will convert this type 1 LSA into a type 3 LSA and advertise it in area 0. It will convert the type 1 LSA into type 3 LSA and advertise it in area 0. RTA will also advertise that type 3 LSA to this ABR. When this ABR receives that type 3 LSA, it's going to forward it again as a type 3 LSA in area 2. That way, even RTA can be able to ping any computer that is in this network segment because it's aware. It's aware in its routing table, it will have this network 192.168.1.0. So what you're supposed to know here is that a type 1 LSA, when advertised in another area, it will be converted to a type 3 LSA. And a type 3 LSA is what we call the network summary LSA. Okay, so let me show you the other way around. So similarly, for this network, RTE is connected to this network, and therefore using a type 1 LSA, a router LSA, it's gonna advertise that network to the ABR. ABR is going to advertise it on area 0. It's gonna get to this guy, and this guy is also gonna advertise it to RTD. Remember, anytime a type 1 or a type 2 LSA is advertised outside its area, okay, it's something, this is not right, eh? This is supposed to be type 3. This is not right here. It's supposed to be type 3. So anytime a type 1 or type 2 is advertised outside its area to another area, then it's advertised as a type 3 LSA, a network LSA. And you can see that actually here, it's also advertised as a type 3. So this one here, I think, was just a mistake. It's supposed to be 3 and not 1. So please take note of that. So I hope you've seen how that is done. Okay, so let's now look at this type 3 LSA. What does it have? What does it have? What information does it carry? Okay, so so here on the header we have the type. So a type 3 is normally called subnet for summary network, or it's called network summary. Sorry, what? Not summary network. Network summary. Network summary. So it's normally referred to as subnet. Then we have the link state ID field on a type 3 LSA is used to carry the network ID of the destination network. Network ID of the destination network. So for example, here we are in RTB. We are in RTB. So in RTB, we do display Ospf Lsdb summary, meaning we want to display the network summary. For which network? For 192.168.1.0. So when you do that, we're going to see that the network ID for that network which you want to display is 192.168.1.0. Then the advertising router. So this is the router ID of the router that is actually generating that particular type 3 LSA. LSH and length, they're the same things that we've talked about earlier. Checksum, sequence number, same things we've talked about. Then we have the network mask here. So the network mask is the subnet mask of that network. So for example, this network is /24. That's why the net mask field here is 255.255.255.0. Then you have the metric is the cost. The metric is the cost of the route from the area border router to the destination network, from the ABR to the destination network. And the cost from the ABR to the destination network. So where is RTV here? So here we were simply in RTB. RTB is here. So in RTB, we've simply displayed the type 3 LSA that is advertising this network on area 0. So that is what we've been evaluating in this slide here. So as you can see on this, on the advertising router 2.2.2. So if I go to the previous slide, you can see that advertising router. Okay, maybe they did not really use. They did not. Oh, okay, yeah, it's okay. It's the router ID of this particular advertising router. Yes, exactly. So the router ID of the ABR, the router ID of the ABR, because it's the ABR that generates this type 3 LSA. Okay. Now, here, inter-area route calculation. So for example, let's see RTA again. Sijui kama wametumia hii. Yeah, wametumia hii. Good. So if we look at RTA, RTA is connected to RTB, which is an ABR. It's also connected to RTC, which is an ABR. So if RTA wants to reach this network, how does it do that particular calculation in area 0? So let's see. So generally, when RTA receives the type 3 LSA, it will know that if I want to go to this network, then I need to forward that packet to the next hop. And the next hop is simply the ABR that advertised that type 3 LSA. Similarly, if it wants to go to the 2.0 network, it knows that this is the ABR that advertised that network. So I need to send that packet to RTC. Then RTC will deliver it to that particular network. So that is how routes are calculated. So we can also look at RTE, which is in area 2. So RTA was in area 0. So let's have a look again at RTE and where it is in the network. So we have RTE here. It is in area 2. So if RTE wants to send a packet to this network, it knows that it needs to send it to the ABR that advertised that network, because the ABR advertised that network to this guy. So the ABR is going to be the next hop. So generally, that is how routes are calculated. Inter-area routes are calculated. In case, for example, it's important that I also mention this. In case, for example, we had another ABR here, if we had another ABR here, so let me just do that. And it's also connected to RTA and also connected to RTE. So it means that both ABRs are going to advertise a route to this network, a route to this particular network. They're going to be advertised by both ABRs to RTA. So when that happens, the route with the lowest cost to the destination is the one that is going to be preferred. Otherwise, if they have the same cost, then the router is going to perform what we call equal cost load balancing. So 50-50, send data 50-50 via both ABRs. Okay. So that is just what they were showing you here, that if RTE wants to send a packet to the 1.0 network, it will simply send it to the ABR, which is RTC. Then RTC will know how to forward it until it gets to the 1.0 network. Okay, so let's look at inter-area route loop prevention. So how can a loop be generated? How can a loop be generated? In this particular network, we have 4 areas: area 0, area 1, area 2, and area 3. Now, let's use RTD. Let's use RTD as an example. So RTD advertises a router LSA advertising this particular network in this area 1. So when that happens, then RTB, because it's an ABR, it's gonna forward that as a type 3 LSA to this particular area 0. So it's gonna forward it like that. So when that happens, when RTC receives this type 3 LSA, it's also going to forward it to area 2 as a type 3 LSA. When RTE receives it, it's also going to forward it in this area 3. So flag it there. When RTD receives it, it's gonna inject it back to area 1. And you remember this type 3 LSA was actually originated from area 1. So when it's injected back to area 1, it simply means that we now have a loop. We have a loop. So that is how a loop can occur. So how does Ospf deal with the issue of loops, inter-area routing loops? So generally, Ospf specifies, Ospf divides areas into 2 major categories: what we call the backbone area, which is normally named as area 0. So this is the reason as to why, if you're having a single area Ospf network, then you should configure it as area 0. Now, all the other areas, 1 going forward, are what we refer to as non-backbone. Areas. So we have what we call transmission rules of type 3 LSAs. We have what we call transmission rules of type 3 LSAs. So the first one is this: all non-backbone areas must be connected to area 0. So they must be connected to the backbone area. That is number 1. Number 2, all traffic between non-backbone areas must pass through the backbone area. So number 1, non-backbone areas must be connected to the backbone area. Number 2, all traffic between non-backbone areas must pass through the backbone area. Then type 3 LSAs. Type 3 LSAs cannot be injected back to the backbone area. Type 3 LSAs cannot be injected back to the backbone area. What that means is this: a route originates from this backbone area, then the ABR from this non-backbone area, the ABR forwards it as a type 3 LSA to the backbone area. So the backbone area is going to share it to the other non-backbone areas. So what we're simply saying is we cannot inject back this same route type 3. We cannot inject it back to the non-backbone area. Therefore, we cannot have a loop. We cannot have a loop. Now, Ospf requires that an ABR should have at least one interface belonging to the backbone area. So that is one of the requirements. However, this is never the case due to improper network planning. So we are going to see if you didn't plan your network so well and you're having some areas that are not connecting to area 0. So what's the solution to it? But generally, that's the recommendation. Okay. So what will happen if the area ID is set to an non-zero value when only one area exists? It means that your network really cannot grow. You cannot be able to create other areas if you don't have an area 0. Okay. So let's look at what we call the virtual link. I want to look at the functions and the configuration. Now, as we said, Ospf requires that an ABR should have at least one interface belonging to the backbone area. But this is not always the case. Why? Due to improper network planning and the connection between the routers. So sometimes you might get that you have your area 0 here, you have your area 1 here, you have your area 2 here. So are you seeing that there is a problem? Why? Because the ABR for area 2 is not directly connected to area 0. So what happens? And remember, this is the recommendation. Why? So that we can prevent inter-area routing loops, inter-area routing loops. So what's the remedy for this? What's the remedy? What's the remedy for this? So the remedy for this is what we call virtual links. Virtual links. So normally, when you talk of that every ABR must have one of its link on area 0, we normally call that contagious, meaning that the backbone area must be contagious. That means that all other areas must communicate through the backbone area. However, the backbone area must not be physically contagious. It can be logically contagious. That is, you can be connected to area 0 through a virtual link, as what we are seeing here. Now, in this particular example, we want to connect area 2 to area 0 via what we are calling a virtual link. A virtual link. Now, normally, a virtual link is set up between two ABRs. Between two ABRs, one that has been connected to that area and another one that has been connected maybe to the backbone area, like what we are seeing here. So how to do that? How to do that? If we want to create a virtual link between RTC and RTB to interconnect area 2 and area 0, then we go to OSPF1, where we go to that particular area. So this virtual link is being created to pass through area 1. So we need to go through, we need to specify the area 1. Then we use the command vlink peer, then we use the router ID. The router ID of the router. So here, when we say 3.3.3, it is the router ID of RTC. So similarly, you have to do the same in order to ensure bidirectional communication. So on RTC, you also come and do vlink peer 2.2.2.2. So when you do that, then R2, area 2 devices can be able now to communicate to area 1 devices because packets will be sent to area 0, then back, in order to prevent what we call loops, inter-area routing loops. Okay. So the network summary LSA. Can one network summary LSA describe multiple routes? I don't think I mentioned this, but can one of you try? What do you think? Do you think a network summary LSA can describe more than one network?
No.
Exactly, that's the answer. So, as we saw in the network summary LSA here, a network summary LSA can only describe a single network. So it cannot carry more than one network. So just a single network. So of course, from this, it will just show this network summary LSA. But generally, each link state advertisement type 3 link state advertisement will only advertise a single network. Okay. How does Ospf prevent inter-area routing loops? So for that one, let me leave you so that you meditate upon it and also read about it from the answers that are provided below this particular slide. Is that okay?
Okay.
Okay.
But is there something you've just described, Alma?
Exactly, but there's no harm in you just read the explanation in the section there. Okay. Anyone with a question, by the way? So Melewa type 3 LSA. So now you know three types of link state advertisements. So network summary LSA is generated by which router?
MBR.